Hey, let's take a look at this projector here today. There's nothing majorly wrong with this thing. For the most part, it seems to work. It does display stuff. However, the only slight issue is that the LED seems extremely dim. This is an LED projector. It's an inexpensive unit. And while it doesn't have like any markings that would tell you what model or anything it is, as you can see on the bottom there, all it says is LED projector. Just some quick searching on the bay and just some general following links and stuff to these things. It brought up that this is apparently a UNIC, I don't know how they're supposed to pronounce that. It's like UNIC, and it's a UC46. That's like an actual model number. Otherwise, you just find it by like LED projector, 1080p by whatever, something 4K. Yeah, this thing does not support 4K. It doesn't even have an actual 1080p output. It's 800 by 480. I don't know. You tend to find a bunch of the ones that look the same, and the specs kind of vary a little bit. It even says Wi-Fi, but I'm not sure if it even actually does have Wi-Fi or not. I don't know. We'll find out. What it has is like here on the side, it's got a few inputs. It's got headphone output right there, AV, that's for like composite video, and then it's got some HDMI input. It's got SD. It will play video files and picture files apparently off of SD and USB. Then it also has like a out that says right here on the USB, it says like out 5 volts. So I'm not sure if that one's like for plugging other stuff in just for powering it or for what. And on the opposite side, all we have is the power connector. So as I mentioned, this unit will power up. If I push this power button, we'll see that this LED becomes solid white. There's a fan inside of it that starts running, and we can see we do have some light output, but it's so dim that it's like not drowning out the camera or anything. I mean, you can't even see this. Even in like full darkness, you can barely see like anything being projected. So I thought we'd just open it up and see if we can do anything about that. This does not actually belong to me. This is a friend of mine's. He just kind of let me use it for the purposes of this video. Most part in to see if I could just get it working. He kind of does want to use it for like one of those ghost things like on Halloween where they shine it like at a curtain and it looks like there's like a ghost flying around the house, something like that. And yeah, in the state it's in, it's really not going to be useful for that at all. So I've already taken the liberty of taking the screws off the bottom. We're just going to power it off, and this top looks like it comes off fairly easily. I'm sure we're going to have like something here, a ribbon for these buttons, because that's still attached. But the top, yep, there it is. So I just gotta disconnect that, and that's easy. Just unplug this here. Okay. So I really did not expect to see much in here anyways, because this thing's like super light. So it looks like the majority of the electronics are going to be on this board. This ribbon here appears to be the interface for the actual LCD. There's some other stuff going on back here. This looks like a power supply. I can see a transformer in there. That's a heat sink. So I don't know if this fan is only for cooling off the power supply and not the LED. So we got to figure out how exactly they're lighting this up. This lens assembly here is like super loose. It's got focus right here and keystone adjustment right there. So that's just like adjusting like the angle of the probably like the last lens before it actually hits the projection lens assembly part of this thing. There's the fan, so that's what's making noise. It's looks like it's a blower design there because it's got no vents here, as you can see. So it looks like it might be blowing air out of that. There is another heat sink here. It looks like it's got some heat pipes. So we will see where those go to. I have a feeling the LED is probably going to be like down underneath here then. What else do we have to remove? We got a few little screws. We got one right there, and then we got a few on this board, a few little other things to disconnect. Once again, I'll be apologizing if the lighting's bad. I'm hoping it's not too terrible, but we'll make do. So I already removed the 3 screws that hold this board in place, and then the one that holds this like plastic cover in place. And this ribbon should just pop out of there. That's right. And then it's got a couple other connectors here. This one that I'm pulling out now, this goes to the fan apparently. So let's see, this cable here is gonna hold it down a little bit. but it's right underneath that, so it should come up. And these connectors on the end here are kind of holding it down, but there we go. Now that's free. Oh, there's actually two connectors over on this side. I'll show you the other one in a sec. So this unplugs, and not really any surprises for seeing a chip like this on here. Basically, this is one of those like all-in-one. It's got all the video inputs and the interface and everything. I mean, obviously, I don't know the specs of this, but I mean, it's common to see those inside like LCD TVs, like, you know, like really inexpensive units. They usually have that kind of stuff. So just got to remove these other two connectors. This one's probably going to be for power, I'm guessing, coming in. This is for the front panel buttons or top panel. So I'm just gonna leave that one intact. So yeah, that's all that's on here. And what else do we have in here? All right, looks like the LED might be down here. So maybe that's the actual power for the LED? Because yeah, like I said, this looks like it's coming from the power supply. Let's see if this cover here comes off somehow. Oh no, we got another screw right there. So after I remove that, it looks like it might come out. And I just dropped it inside out. If I just give it a little flip here, it might come out. Ah, the lens wants to come out. Let's just see if we can pull this out. I don't want to drop this. Well, it's coming off anyway, so. Hidden screw right there underneath that ribbon. So, and this thing just flopped out. No worries. It's all kind of self-contained, so I'm just going to set that aside. Well, if you want to take a quick look at it, that's what that is. So, fairly big projection lens assembly. But it's already magnifying kind of a big image, so hey, check it out. You can see stuff projecting onto my arm there. What is that? Is that... I can't tell what's magnifying. Something. Alright, and this other ring that fell in here. Oh, that's like not even a full ring levered right there. See that? So I can stay on there. No big deal. Okay, that screws out now. So now this cover should come off. Unless something else is holding it down. Nope, there it is. Okay. So we've got a little Fresnel lens right there. That's what adjusts the keystone. So the image is being projected from, well, the image is being formed right here. That looks like it's the actual LCD, but I can't pull it up just yet, so I'm not going to bother. At least they use a surface mirror on this side. It avoids getting kind of like a double image. It looks like we've got another Fresnel lens right here, right before the LCD. We've got two more screws holding this shroud here in place, or this cover. But looks like if we just remove the stuff holding this in, we'll be able to see where the actual LED is at. Okay, all the screws are off of these shrouds here and these covers, so this should come up. Well, looks like this one might come up first. That just comes right out. But yep, little blower fan. So it's pulling air through here, blowing it out through here, going through these fins, and that is cooling the LED, which is down there. It's like one of those little cob ones. What do we have to remove to pull that out? I'm not sure. Actually, it looks like it'll just come off just like that. Okay, well, this is sort of interfering, so let's go ahead and pull this out. Another Fresnel lens right there. So it's got a reflector inside. The light goes in through there, and that's where the light comes out. So it looks like there might be something wrong maybe with the LED itself, unless there's something wrong with the power supply and it's just not providing enough power. They don't look burnt. See that? Does not look burnt at all. Looks like there's a little speck of dust there, but that's about it. That comes right off. The little cooling solution they used here actually doesn't look too terrible in my opinion. So who knows? Let's see. Let's go take a look at the power supply then and see if anything suspicious there. But as I can see here so far, it doesn't really look too bad. I guess what we could do is put in the control board power it up and see what these look like. We should be able to just kind of bring this off to the side here. Just kind of lay it here on the side and see what these LEDs are doing. We don't necessarily need to have the LCD connected, I don't think, to have it power up. So let's try that and see what it does. I've got a very minimal set of stuff here plugged in. So I've got power coming into here. And this is not exactly very well insulated on this side. They didn't put like heat shrink or anything on those wires soldered to the actual connector. So it's one thing to be careful with if you're working on one of these things. I plugged in the fan just in case for some reason it's got to detect, like RPM from the fan, or it shuts off or something. And then this is the ribbon coming from the power supply to the control board. So that's really the only thing I hooked up. I didn't hook this up because it turns out that's just the speaker. There's the LED. That's obviously hooked up directly to the power supply, so it should work. I'm going to go ahead and hit power now. And the power button up here. So push that. It should come on. And there it is. Oh yeah, wow, that's way dim. You can see how that looks like when we put this on there. I mean, it does help with the light a little bit, but you can still see that it's really, really not that bright. As far as I can tell, all the actual little elements, they're all actually lit up. So the problem is not going to be the LED, I don't think. And this thermal cutoff is obviously not the problem because, I mean, it's lighting up. So I guess we could check and see what kind of voltage we're getting at the input. I have a feeling maybe there's going to be something wrong with the current sensing part of this. And what it might be happening is that maybe it thinks there's more current being driven to the LED than actually is. And so it's limiting itself. It could be that there's maybe like, some terrible solder joints or something in that power supply. So we will look there next. There's really nothing holding this power supply in place, so this actually just slides right out. Just got to be careful not to touch any potentially charged mains caps, because I have a feeling there probably are. There's the underside, and all that flux residue looks pretty terrible. I think there's a screw here holding this side panel, and yeah, if I remove that, I can pull this off because this connector is actually like snapped into the plastic, and I don't think I really want to bother removing it because it's soldered on the back, so it's not like I can remove anything from there anyway. So I'm just going to remove that screw. That should release this whole side, and I can maybe like kind of bring this outwards that way. Alright, so there's actually two screws there, and it's not necessary to pull them all the way out because this is just slotted in there, so it just kind of fits in there. You tighten them down. If you just loosen them up, this side will come out. So that's that. And we have a connector for both the LED. That's that. And we have a connector for the low voltage power supply stuff going to the control board. So we can pull that off as well. Just like so. And that is the power supply. Oh, I wish I would have noticed that. There's actually another connector there for the mains input. So we can just pull that off as well. Comes right off just like that. And that just leaves us with the bare power supply. There's really not much on the top side. It's both a through hole and surface mount. But we can easily see that there's going to be just like one section for the LED there, and then this right here looks like it's just a transistor for, not sure what that one's for just yet. I don't know if that's for the LED or not. This one right there looks like maybe it might be a MOSFET that goes to one of the LED pins right there. We'll zoom in on this a little bit better. I'm just getting a quick look, to see what all's on here. Right there, those two, those are going to be our current sense resistors. This could be maybe being used as like a linear regulator, not sure yet. See, we got a couple of opto isolators right there. A couple of these outputs right here looks like they're in parallel, so we have, we'd have like our ground and then maybe like a positive there going to the main control board. We got a couple other two, maybe one's for like turning on the LED and the other one's for like dimming. This is only a 6-pin or a 6-position connector, so I think that would make sense. Here we are with a much closer look at all the nastiness and crustiness on this power supply. Probably could take some alcohol and a brush or something and clean most of this off so it makes things easier to see. You can see these pins that the solder didn't completely like flow all the way through. It looks like they are making contact because on the opposite side They are, you know, looks like they flowed pretty well over here, but that side doesn't look so hot. So yeah, I don't know exactly what the issue is just yet. You can tell that this here's a MOSFET because all four of these are connected in, you know, are connected together. So that would be like the drain. This here would be the source. That would be the gate. And this looks like it goes to this pin, I think, right there. So these right here are both for the LED. So this would be the like an N-type MOSFET, because you can see this contact here, which is for the LED, goes directly to a positive, which is positive right there. So that's that capacitor. And it looks like this winding from the transformer gets rectified by this diode. It comes off to here. There's a little bit of filtering right there, a little capacitor. And this is another capacitor. That goes through this little choke. This choke goes to that. So a little bit of filtering there for that output. That's for the LED. So the negative goes through these two resistors. There's another one right there. I thought maybe these would be connected in parallel, but it looks like they're not. So this is being the source. So it gets its negative from, looks like maybe these two are connected together. If we look at the other side, we see how that ground plane goes to one of those pins on the transformer, and that's the negative for this big capacitor right there in the shot. So what's happening is the negative of that capacitor, it is actually connected directly to this transformer. It's just the one going to the LED that goes through this resistor. So this right here should be a fixed voltage. I don't know what it's going to be, but it's going to be something stable. It's not going to be adjusted for the LED. This MOSFET is the one that's doing the regulation for the LED. We see that this positive also comes up to here. It goes to that, it would be the center pin of this device here, which kind of looks like a voltage regulator, but the numbering kind of says transistor to me, although I haven't looked it up yet, so I'm not sure what it is. That little solder ball right there underneath that resistor. Jeez. This here is going to be the output coming to the connector right here for the main board. And that's the pin that goes to an optocoupler. So this is probably going to be the one that activates the LED. The other pin, it doesn't look like there's anything going on with it down on this side, but there might be something on the opposite side. I'm going to give this a really good cleaning before we go too much further, because it's way too hard to see anything with all that crud in the way. Okay, so that second pin in on that connector looks like it's actually going to the optocoupler as well. So it looks like what they're doing is that's a positive and the negative going to this optocoupler, and then the other side is the one that has like the photo transistor, and that's how they are controlling the LEDs. So this has like nothing to do with activating anything on this power supply. It just basically pulse width modulates the LED. At least that's my guess at the moment. We'll be able to check that later. And then these are just providing power to the main board. Oh man, is that much better or what? So much cleaner, much easier to see what's going on. And nothing looks obviously bad. We can actually check the voltages. We can check the voltage coming out of this transformer. It's single voltage supply coming out. You know, it's regulated by that, and then that's what goes out. So let's see what sort of voltages we're getting out of this, out of here, and when the LED's on, let's see what we're getting from there. Okay, we got everything set up here. Got the multimeter there right up in your face so you can see it. And the power supply now, I have it connected to mains. I do have the wire back here. It's plugged in, so I just got to make sure I don't touch that. And I got to make sure I don't touch anything over here. But let's check and see what voltage is present at the main filter cap coming out of the power supply. So about 16.7, so about 16.8 volts. Let's see what voltage actually goes out to the main board. 15.3. Interesting. I would have thought it would have been less. I don't know. I would have at least expected like maybe 12 or something, but I mean, that's like, it's barely even regulating anything. Let's see what kind of voltage we're getting at the actual LED when this unit is on. So I got everything plugged in that's, you know, like necessary. what I believe is necessary, because I don't even know if the fan is totally necessary, but I mean, it doesn't harm anything, so let's just leave it plugged in. I'm going to turn it back on, and let's see what shows up here. So we have 15 volts at the LED. That's really weird. All of a sudden the LED went like super dim. You can see that not even all the elements are like lit up now. The voltage measures about 13.8, but it wasn't like it dimmed out or anything. It like started flickering. So I don't know what that was all about. The voltage on the power supply, now it's reading 21.1. But okay, so I turned it off and I turned it back on, and the LED is not going back up to the same intensity. So that's a little weird. Alright, here at the MOSFET, if I hook up the positive lead to the drain and the negative lead to the source, we got about 7 volts there, so it's almost like it's not fully switched on. If I check the gate and I hook this one to the ground, we have about 1.77 volts at the gate, but that could be, like I said, like a pulse modulated signal going into that, and I'm gonna have to, you know, probe it with the scope to be able to see what's actually going on there. It just seems, yeah, very low. But over here at the optocoupler, if I hook up the positive and the negative to, you have 1.09. Again, I don't know if this is being pulse width modulated or not, so I'm gonna have to check that. So time to get out the scope, I guess. And that's the only way we're really going to be able to see what's actually going on. Before we do that though, let's see what this LED does if we hooked up the negative lead directly to ground, because we know that the positive is hooked up directly to the positive output of the secondary side. So let's see how bright it is if I just momentarily touch this to ground. Wow, okay, that was super bright. Yeah, this LED has potential. So it's not the LED that's bad for sure. Yeah, that's extremely bright, as you can see. So, yep, not the LED. It's something else that controls it. I think we've got things more or less set up here. So I got the scope set to 2 volts per division, and right now it's at 50 microseconds. I don't know what we'll actually need, or if we even need to change anything. I've got the ground lead from the scope on the cathode of that optocoupler. And this optocoupler is one of those like 817 numbered parts. There's like PC817, there's like K817, and like some other ones depending on the manufacturer, but they're pretty much, they seem to all be like pretty similar. It's just got like the LED on one side, and then the other side it's like a photo transistor. So I have that on the cathode side, and I've got my probe that I'm going to touch to the anode side once we power it up, and we'll see if there's any like pulse width modulation going on, or if it's just like a constant on, or whatever. We'll find out. So let's see, I've already got it plugged in, got the LED over here blinking, so I'm going to power that up, and it's going to take a sec, and once the fan starts spinning I think we're good. Okay, it's spinning. The LED down here glowing. Let's see what's going on at this pin. Alright, so it looks like it's just a constant on there. So let me move around this timepiece here, but I doubt that there's any difference. It looks like it's just a constant. Yeah, I don't see any pulsing going on like at all. If you go out or we go in, yeah, nope. This is just basically like a constant on. Alright, so that's constantly on. Let's see what happens if I have the ground hooked up to basically the ground on the power supply, and I touch the probe to the gate on that MOSFET. As we see, we only have just under 2 volts right there. So maybe the problem is somewhere in between that input and the MOSFET. I was starting to think, well, maybe something wrong with that MOSFET, but if that voltage is so low, I'm not sure. Well, this area here, it's simple enough that I could probably just sort of reverse engineer it a little bit. one quick little thing that I thought we could try. So on the optocoupler, when the LED side is on, basically it allows current to flow through the phototransistor on the opposite side. Basically, you know, like closing a switch. So let's see what happens if I just jump that straight across on the opposite side. Will the LED fully come on? Or will it just stay the same? I have a little flathead here, and it doesn't seem to be... Oh, yeah, it did. Yes, it did. Aha! Could there be something wrong with that optocoupler? Look at that. Or is this voltage not high enough on the other side? I don't know. 1 point whatever it was right there usually seems to be about a good voltage for those optocouplers, but I guess if I start anywhere, I could start by replacing it. Man, that big chroma display would have been cool to have right about now, but I have to make do with paper and pencil. So anyways, what's going on here is actually a lot more simple than I thought it was originally going to be. Turns out the majority of the circuitry on this side of the circuit is not for actually regulating the LED. It turns out it's mostly for voltage regulation for the switching side. I mean, it goes through the other optocoupler that's like up here, but it's not meant for this MOSFET. So the circuit driving the MOSFET is actually extremely simple. So here's the optocoupler that comes from the main board, the one that's supposed to turn on the actual LED, and the collector from that is connected directly to the regulated positive. This is the positive that feeds the main board as well. The other side, the emitter down here, it comes out and it goes to two resistors, two 100 ohm resistors. One of them goes to a little transistor that I'm pretty sure it's going to be an NPN, and that's also part of the feedback circuit. So what I think is happening is once the main board turns this optocoupler on, it actually makes the voltage on the regulator go up. So that way what's happening is when this thing is just in standby, it's outputting a lower voltage, but it doesn't need to have a higher voltage because the LED is not on. And then once it's on, you know, it steps with the voltage. So the other side of that goes through a 100 ohm resistor as well, and then that goes directly to the gate of it's an alpha omega 4726 MOSFET, and the negative from that goes directly to the LED. So, and then the source goes to those two big chip resistors. They're 0.05 ohms each, and then the gate has got a 47k ohm resistor and a little capacitor. They're both connected in parallel. So there's really nothing here that's going to be doing like any switching. This thing is not going to be turning on and off, because then that would make the voltage, like, you know, be constantly fluctuating as well. So it's, yeah, that's all it does, is it turns it on, LED's on, and that's it. So it looks like our problem is this guy. So here's another quick little test we can do just to make sure that optocoupler is getting a proper, like, you know, current to light it up. I have just a regular LED right here, and I plugged it in straight to those leads that are supposed to go to that optocoupler, and everything's powered up. I have this LED in place here, but it's not going to do anything because there's no signal going to the optocoupler. Okay, so I'm going to hit this power button, and it should come on. Power is on. Okay, fan's running, and as you can see, this LED has no trouble lighting up at all. Okay, so that's cool and all. We've pretty much identified our issue. It's very likely that it is going to be that optocoupler, and we just replace it, right? Well, easier said than done, because I do not have any of these optocouplers on hand. I mean, I could order some, but I would really hate to do that just because of the fact that I have a bunch of these, but they're in a storage unit about 2 hours away from here, so I can't get one like right at this moment. However, I am going to be making a trip up there fairly soon, so maybe I'll just go and get me some, and I'll bring them down with me, and then I can, you know, just swap it out, and it should be okay. I mean, I don't see any reason why it wouldn't work. So I guess maybe I'll just leave this video here for now. When I do get the optocoupler, you know, we'll continue it and see if this is actually going to work. I'm fairly confident that it will. In the meantime, I can basically like put everything else back together, because I mean, none of the other stuff is an issue, and I can just plug this in, you know, like after the fact, after everything else is put back together, and I replace that optocoupler. Unfortunately, I also don't have any nearby stores where I could buy one, so I'm kind of hosed in that aspect. Alright, so yeah, give me a few days and I'll get me some optocouplers. I'll bring them down. I'll swap it out. Hopefully it works. So in the meantime, thank you guys for watching this, and I will see you guys around the bench again soon. How does this go in?